confident that you can forecast. Okay, so now we're going to talk more about what my specific research is, and that is using the Arctic sea ice cover for an idea of what's going on presently. Who knows what's sitting right there in the front of the map?
It's Alaska.
Alaska, exactly, the thing that makes us an Arctic nation. And in front of it, at the top there, is the Arctic sea ice cover. It's a wonderful picture of the Arctic sea ice cover. You can see it's bright and it's white. It's one of the pieces of the planet that actually helps keep us cool because it sends sunlight back to space. I can tell that this is a summertime picture because of the fact that I can see that the ice cover is pulled back from the coastline here. It gives me a sense of seeing the big difference between an ice cover and an ocean. This is sending sunlight back to space. This is absorbing sunlight. And let's look, we are really able to see how this is changing with time. This is a plot of the temperature on the planet for over a century. Okay, and it's plotted as an anomaly. You guys know what that is? So basically what you've done is you've taken all of the information that you have, you put it into a pot and you get an average. And then you look at, for each year, how much that deviates from the average. And what's most important for you to see in this plot is anything above zero means it's relatively warm, and anything below zero means it's relatively cool. Okay, so what you can see, again, observationally, that there's been a general warming trend since the 1980s on the planet. Now, if I look at what's going on in the Arctic, I can see the same kind of warming trend, okay? You have the same shape, and you have the kind of uptick towards the end. But what I want to draw your attention to is the change in temperature. If you look globally, the temperatures have increased about 1 degree. In the Arctic, they've increased by about 2 degrees. So the warming that's going on the planet is happening much more quickly in the Arctic than it is over the globe, and this is what we call Arctic amplification. And I hope by the end of this little chat that you'll understand why that's happening. Okay, so the question is, what's the impact? Not what I wanted. Go away. Okay, now satellites do a really good job of monitoring changes in the extent of the ice cover. And they can do that regardless of what the weather is, whether it's polar night or polar day. And they can show us, for instance, the seasonal change in the Arctic sea ice cover. Here you can see the sea ice cover in February on the left-hand side. That's about the time when the sea ice cover is at its largest. Okay, remember it's dark and it's cold in the polar regions in the wintertime, so the sea ice cover grows to its biggest extent. And in the summertime, in about March, February, the sun comes up and things begin to melt. And the Arctic sea ice cover retreats from these far reaches into the core. And it reduces to the ice cover that you see over on the right-hand side. And you can actually see that the ice extent over just a season changes by it's about half the size it is in the wintertime. Now what I want to do is take a snapshot every summer for the time that we've had satellites available. So that started in 1979. And we're looking at how small the sea ice cover got every year in the summertime. You see that plot over here. What do you see about the Arctic sea ice cover in the summer? Going down. Why is it going down? Why? Right. And again, for a sea ice cover, this is not good news. All right? I mean, that's about as basic as it gets. That's why my job is actually pretty easy. What you can see is the fact that in the past few years, the decline has been massive, and we look at what just happened this past summer, we set a new record for the size of the sea ice cover. It was the smallest sea ice cover that we've observed. Over this satellite period, we know from historical records it's actually the smallest sea ice cover we've seen in hundreds of years. Now, it may be hard for you to get a sense of how much change, so we've kind of come up with this analog. The Arctic sea ice cover in the summertime in the 1980s was about the same size as the United States, the lower 48. All right? So what I want to do is show you, before I just have to And here shows you, I'll just back up. This is 1980, and this is this past year. Okay, so you see a reduction about 55% smaller. It's a huge reduction. I said now I'm going to use the analogs for the United States. Here's the summer sea ice cover 1980, about the same size as the United States. This 55% reduction looks like this. Okay, so over half of the United States, lower 48 would be gone. That's a lot of change in the Arctic over 30 years. Now, if we look in the winter time, what we see is it's not as much change as in the summertime, and that's actually easier for you to see here where I plot both the summer and the winter time. Okay? You can see the summer dipping down, the winter is going down too, but it's not as massive a change. Now, when the winter ice cover comes on, this is when I get a lot of phone calls saying, well, nothing's really changing. What do you think is happening, though, with the Arctic sea ice cover if it's retreating? When that ice cover comes back, what's different about it?
Not as strong.
Not as strong, for sure, but why isn't it as strong? It's thinner, exactly. And here we can see some evidence about how thin it is getting to be, relatively speaking. In the top left-hand corner, you see the distribution of ice thickness over time. White is really old ice, and blue is younger ice. So you can see in 1980s, the basin was filled with this older, thicker ice. Look at the content now. Much thinner ice cover. Much more vulnerable to thinning. Okay, so not only is the ice cover extent reducing, but the ice cover is getting thinner as well.
What kind of thicknesses are we talking about?
Sorry. Okay, the thickness of the ice cover will grow on its own probably about 2 to 3 meters thick. Okay, so 6 to 9 feet thick. But then there's this massive piling up that goes on. And if an ice resides in the Arctic for periods of time, it could get to be up to, I've drilled through ice covers that are 30 feet thick, so 10 meters. So it's much thinner now than it was before. Now what's important to remember when I'm talking about the Arctic sea ice cover, it's part of a larger system. So you see here we have a reduction in the ice cover right here. Pull back. When this pulls back, the ocean begins to warm, okay, because it's darker and it absorbs sunlight. When that happens, you get these warm air masses, and those warm air masses cause more melting. So you get this Arctic amplification. Now what's at the core of the Arctic amplification is this puppy. Who has heard about albedo? Okay, you don't give count. What's an albedo?
Sunlight reflection.
Exactly. Right. This is a really important concept to have when you're talking about changes in the planet, and particularly the Arctic sea ice cover. Here you're talking about an albedo. It's this really nice ratio of the reflected sunlight to the incoming sunlight. Right? And so it can vary between 0 and 1. That's it. Okay, and the reason, let's go back for a minute. So if I have a perfectly white surface, what's happening to all the sunlight?
Getting reflected.
It's reflected. So what is the number on the top?
1.
Exactly. So what is the ratio then? 1. Okay, how about if it's perfectly black?
0.
0. That's it. You've got albedo in a nutshell. If I walked around this room now and said, I pointed like to my jacket, is that an albedo that's going to be close to 0, or is it going to be close to 1?
Right onto it.
Huh?
Right onto it.
It's going to be close to 0. And how about this tablecloth?
1.
Okay, and if I brought in an instrument and got a measurement, you guys would be about right. It's an optical measurement, so you can actually measure it really easily with your eye. Now, when we talk about the Arctic sea ice cover, we're talking about an ice cover that's one of the most naturally reflective surfaces on the planet. It has an albedo of about 0.85. Nothing's perfect in nature, so it's about as good as it gets. When you talk about the ocean has an albedo of 0.05. So when the Arctic sea ice cover shrinks, you're replacing one of the most naturally reflective surfaces with one of the most naturally absorbing surfaces. So it makes a big change in basically the thermostat on the planet. What was helping keep our planet cool is now making it warmer. So you basically get this vicious cycle. You get absorbed sunlight, that causes things to melt. If this was working, you could see it. Oh, there it goes. And then you get lower albedo, and you get more sunlight melting, albedo, and you get what this positive feedback cycle. So now you've been taking a trend and it's been going slowly down. You get into one of these cycles and it accelerates it, and that's what we're seeing with the Arctic sea ice cover, where it went down and it's just begun to plummet. It's feeding back on itself, and this is why we don't expect this to reverse itself. That make sense? Okay, and there are other indications of how the Arctic is changing. It's not just the Arctic sea ice cover. If we look at Greenland, this past year set records with regard to the amount of ice that was lost on Greenland. Guess what happens to ice that goes off of Greenland? Where does it go into? The ocean. What happens with regard to the ocean then?
Sea level rise.
Sea level rise, right. Now the Arctic Ocean, the Arctic ice cover, doesn't have any effect on sea level rise because it's already a floating ice cube. But with Greenland, you're actually adding water to the ocean. We also see that we had record low summer snow extent on land. That's like the Arctic sea ice cover too, because when the snow goes away, it reveals darker land. So that's changing the albedo as well. And also what we can see some things like the fact that around the periphery of the Arctic, where the sea ice cover is retreating longer during the year, we actually are starting to see more vegetation growing. It's getting greener there because it's warmer and nicer for plants. So a lot of things are going on, not just the Arctic sea ice cover. So then the question is, what's going to happen in the future? And so what we expect to have happen in your lifetime, estimates are probably in the year like 2030, 2040, will actually have an Arctic that is ice-free in the summertime. And that changes a lot. The reason we feel really confident in saying that is because all of the projections that are out there for all the models indicate that through this century, temperatures are going to continue to warm. Okay, every model agrees about that. And the projected increase is that the Arctic will still continue to warm more than the rest of the planet, actually expected to warm 4 to 8 degrees centigrade. Again, if you're in an icy environment, this is bad news. We mentioned that the Arctic sea ice cover is not only losing its extent, but it's thinner, much more vulnerable to melting, and will melt faster in the summertime. And finally, we have these cycles that are accelerating it. So we feel very confident in our expectation the Arctic sea ice cover is going to be, or the Arctic is going to be ice-free in the summertime. It will still grow back in the wintertime, but it'll be a much thinner ice cover. So then the question is, what are the impacts? So here's a picture of the Arctic sea ice cover in the summertime. Now this was this past summer. And you can again see that when it melts, it comes back to its core. So the question I have for you is, what is this going to change? And I'm just going to jot down some notes. Tell me some things that this impacts. If the Arctic sea ice cover is looking like that, what's going to change? Yeah?
Higher sea level.
Nope.
Oh, okay.
Do you remember why? Here's an experiment. Think about this experiment, okay? You have a glass of ice water that's completely filled to the brim, all right? And you let it melt. Is it going to overflow?
Yeah.
No.
What happens with regard to ice cubes? Are ice cubes take up more volume than the water does? So actually the level will go down a little bit. Try it at home. Try it when you go back to your room. It's not going to, it won't overflow because that ice cubes are already floating in the water. So, on that one. Yeah.
What'd you say?
Pardon? Salinity will change, yeah.